Okay, we're going to work now assignment 8, problem 52. So it says a projectile is launched at an angle of 30 degrees. Before I even start doing any projectile motion problems, I'm going to write my given. The difference with these type of problems is I'm going to separate my horizontal and vertical component, and I'm going to write my x and y given like this. Okay? Why am I going to do that? Because the x and the y are independent from one another. Now, I'm going to go ahead and write in my given ax is 0. I know ax is always 0. There's no horizontal acceleration, but I'm going to write it because when I want to know which equation to use and which way to start, I'm going to know, do I have 3 things on one side, because all our equations have 4 variables. Okay? So it says the projectiles launch at an angle of 30 degrees above the horizontal. So I'm going to draw my picture, because the picture helps me to visualize. So this is my initial velocity, v0, which is 35. And the projectile is going to end up going like this. Okay. Now, they tell me that v0 is 35. If I'm given the initial velocity and it's at 30 degrees, the next thing I should do is I should take that initial velocity and I should break it up into its horizontal and vertical components. So I like to do it on the side, because when you do it like this, you're less likely to make a mistake. So here's my v0 is 35. From the head of this vector, this is where I start. So this is going to be v0x, and from the head of this vector, I do the tail of the other. This is v0y. These are perpendicular because they're components, and this angle's 30. So I have a right triangle. I have the hypotenuse and the angle. I can find the other two sides. So v0x is equal to v0 cosine of 30. So v0x is equal to 35 times the cosine of 30. And then when I put it in my calculator, v0x is equal to 30.31 meters per second. So now I'm going to put over here, v0x is equal to 30.31. Now I'm going to find my vertical component. So v0y is equal to v0 sine of 30. So v0y is equal to 35 times the sine of 30. So v0y is equal to 17.5 meters per second. And now I'm going to put that in my given. So you see already on both sides, I already have like 2 things on both sides, and all I need is a third variable to find something else, because all my equations have 4. Remember, I've been chunking the problem, so now I'm going to read the rest. And it's in the air for 3 seconds. Now, when I first read this problem before, I misread it. I thought that the total time it was in the air was 3 seconds. But does it say the total time it's in the air? No. So I don't even know, is that 3 seconds occurring here? Is it occurring here? Is it occurring here? Where is that 3 seconds occurring? Do I know? I don't know. So that was the mistake that I made. Now the time is the same on both sides, so I actually have 4 things, right? And just by, this is what the point I want to make, just by misreading one word, would that change the entire problem? Absolutely. So I make mistakes as well, and we have to be careful when we read these. All right. So A says find the projectile range. Okay, so the range, again, is how far it goes, so I want to find x. What do? Well, I have x, I want to find x, I have v0x, I have t, and I know ax is 0. So I'm going to say, well, which equation has those 4 variables? Well, I know x is equal to v0 xt plus 1/2 axt squared, but this goes to 0. You don't necessarily have to write this, but that's where this equation came from. So now when I substitute in my values, I have 30.3 seconds times meters per second, sorry, times 3 seconds, and that comes out to be 90.9 meters. Now remember, I carry my units through to cancel my work. So this second cancels with that second, and I end up with meters, which is the correct unit for my range. All right, let's look at part B. So part B says, determine the projectile's altitude. So I want to know how high it goes. So how high it goes is going to be y. So now I'm going to look at, well, I want to find y. I know v naught y. I know g. And I also have t. So which equation am I going to use here? I'm actually going to use the same equation, but I'm going to use the same equation in the y direction. So now I'm going to say y is equal to v naught yt plus 1/2 gt squared. So I'm going to substitute in my values. So y is equal to 17.5 meters per second times 3 seconds plus 1/2 negative 9.8 times 3 seconds squared. And when I do all this, y comes out to be 8.4 meters. So step by step by step. Part C says to find the final velocity, VF. Now remember, VF is actually going to be VFX and VFY added vectorially. Okay, they say, what is the final velocity? Now, when I look at my picture, I don't even know where VF is. Is VF like this? Is it up here? Is it down here? Where is VF? Well, the first thing I know is that the horizontal component of the velocity doesn't change. So VFX is equal to VF, V naught F, which is equal to 30.31. Let me move this up. So now I have to find VFY. So I want to find VFY. So what do I know? I know V naught Y, I know G, and I know T. So I'll use the equation VFY is equal to V naught Y plus GT. So when I do that, VFY is equal to 17.5 meters per second plus negative 9.8 meters per second squared times 3 seconds. Now when I work this out on my calculator, VFY comes out to be 11.9 meters per second. So this negative is really important. When I want to find now my VF, again, I have my VFX and I have my VFY. So this one is positive. So I have here's my VFX. From the head of this vector, I do the tail of the other. This is going to be VFY. And you notice I did it down. It's down because this is negative. To find my resultant from here to here, this is going to be VF. So this is a right triangle because my vectors are perpendicular. So VF is equal to the square root of VFX squared plus VFY squared. So VF is equal to the square root of 30.31 squared plus negative 11.9 squared. So let's put that one. So the answer should come out to be 32.6 meters per second. And the question said find the final speed. Now if it said the velocity has both magnitude and direction, and I would have to find that angle, but they didn't ask us for that. Okay. It just said what's the speed. Whoops. So again, when we're working the projectile problems, when we separate our givens like this, our x and our y, it makes it easier. Okay, because we're applying our equations in just one direction.